In this lecture, we continue the discussion on association between categorical variables. We were looking at this example in the previous lecture. So, we look at one set of variables which is on time departure and delay in departure, and we have two airlines, let us say we call them XX and YY. So, this is the contingency table that explains this. So, data for 220 flights, and we say that airline XX in 86 instances departed on time and 34 instances there was a delay by a few minutes and so on. So, now let us find out an association. Can we say, for example, whether XX or YY has a better on time departure performance? Merely by going through this data, we realize that airline XX 72% of the times has departed on time, while airline YY 81% of the times has departed on time, and therefore, we might say at the moment that YY has a better on time departure performance than airline XX. So, we tried to answer one question, does airline YY have a better performance? We also want to answer another question, is there an association between the airline and the performance, or is there no association? So, we will define a couple of metrics for the association between the categorical variables in this lecture. But let us continue our discussion on that question, does YY have a better performance? Based on this data, yes, because 81% of the times it seems to depart on time, whereas XX does it only for 72% of the times. Now, we can bring in a third variable which can help us understand, or which can bring in a different perspective to the whole analysis. Now, let us also bring a third variable, which is, let us consider the type of flight, and we might call that flight into two types, which could be a point to point flight or a hopping flight. So, in a hopping flight, we mean that the flight starts at airport A, goes to B and then goes to C, whereas in a point to point it goes directly from A to C and so on. So, let us add this variable and look at this direction, and if we do that, and let us assume that the same data on 220 flights has now been categorized or has now been computed again based on the type of the flight. And let us say now that the 86 flights, which you can see here, the 86 flights has now become 50 flights which are hopping and 36 flights which are point to point and so on. And when we do this analysis, we realize that for hopping flights, airline XX seem to have a better performance than YY, whereas in point to point flights, YY seems to have a better performance than XX. So, what we understand through this example is, when we considered these two types of categorical variables, we concluded that airline YY seems to have a better performance. But when we brought one more variable, which is the nature or type of flight, we now realize that for one type of flight XX seems to be better, and for the other YY seems to be better. So, if it is a hopping flight, XX seems to have a better performance. So, the external variable that influences the performance is called a lurking variable, and the presence or the change through this lurking variable is also called the Simpsons Paradox. Now, let us look at an exercise where we can identify lurking variables and we can see the effect of them. For example, we could look at the scores of two cricketers, and if we want to make that comparison about consistency, then we could think of what types of matches, day match versus day night match, team batting first versus team batting second, batting position of the player, particularly opening position, middle order position and so on. Now, for example, we could look at something like this, greater than or equal to 30 scores, two players AA and BB, and we could have a performance like this. Whereas if we looked at first innings and second innings, then you see that the performance changes and the person BB seems to now have a higher percentage than cricketer AA and so on. So, how do we measure association among categorical variables? So, let us take an example and try to define a measure or a metric to find out the association. Is there an association or is there no association? So, the data that we look at is, let us look at attending classes when the instructor does not take attendance. Now, we have two types of students in the class. We could have fresh graduates who had come into a master's program, and we could have people with work experience who come to a master's program. So, one categorical variable is fresh graduates and students with work experience, which is shown here, and the other variable is they attend classes and they skip classes. So, let us assume we have data for 72 classes where we have this. So, we realize that the fresh graduates attend 12 numbers, fresh graduates who skip 17 numbers, work experience people who attend 28 numbers, and work experience who skip is 43 numbers, making up for 72 number of students in the class, out of which 29 are fresh graduates and 43 are people with work experience, and out of these 72, let us say 40 attend classes and 32 skip classes when the instructor does not take attendance. So, this number 72 represents the total number of people in the class, and that is made up of 29 plus 43 with respect to fresh graduates and people with work experience. Now, we want to know, is there an association? For example, is there an association between attending the class and skipping the class vis-a-vis fresh graduates and people with work experience? Now, let us try to do these proportions one more time. Now, what we try to do is, we now from this data, just for the sake of computation, we leave out these 4 numbers, and then let us say we have total of 29 fresh graduates and 43 students with work experience with 72 students, and let us say we also know this number that 40 attend classes and 32 skip classes. Now, what we try to do is to create these proportions again. Now, the number that we have here is now treated like this. Now, if 40 out of 72 students attend, now if I take only the fresh graduates, let us assume the same proportion attend, and therefore, that proportion becomes 40 by 72 into 29, and this number becomes 40 by 72 into 43. Now, here this number becomes 29 by 72 into 32, and the other number becomes 43 by 72 into 32. So, let me repeat this one more time. Now, we started with this table, and then let us say we found out this in the class, and then we say that there are 29 fresh graduates and 43 people with work experience in a postgraduate class, and we know that 40 attend and 32 skip, making a total of 72 row wise total as well as column wise total. Now, we want to create these ratios again. Now, we want to create these 4 numbers again as ratios, and let me explain how they are created. Now, we say if 40 students out of 72 attend in the class, proportionately how many of the 29 fresh graduates attend the class. So, that number is 40 by 72 into 29, which is written here. Similarly, if 40 out of 72 attend the class, how many out of the 43 with work experience attend the class, and that is given by 40 by 72 into 43. If 32 out of 72 do not attend the class or skip the class, then how much out of these 29 skip the class, and that is given by 29 into 32 by 72. If 32 out of 72 skip the class, how much out of 43 skip the class, which is given by 32 by 72 into 43. So, we can calculate these numbers, and these numbers are calculated and shown here. So, the original data is 12, 17, 28 and 15, and the new calculation, for example 29 into 40 by 72 and 29 into 40 by 72 will be 29 into 5, 5 8s are 40, 9 8s are 72, 29 into 5 by 8, and that would become 16. This is rounded off. So, rounded off to 16, therefore, the other one is rounded off to 13. So, that the total is 29, and once we calculate this 16, we know that this total is 40, therefore, this becomes 24 and the other becomes 19. So, we have data, and then we have these proportions which are calculated, and then we find the difference, and in this case the difference happens to be minus 4, 4, 4 and minus 4. We now calculate a number which is called chi-square. This is chi-square, chi square, so called chi-square, which is given by 12 minus 16 the whole square by 16. We had this 12 minus 16 the whole square divided by this 16, 17 minus 13 the whole square divided by this 13, 28 minus 24 the whole square divided by 24, which is here, and 15 minus 19 the whole square divided by 19, and when we do this computation, chi-square becomes 3.74. So, we calculate this number called chi-square, which is 3.74. We can also calculate another number called Cramer's V, and this Cramer's V is given by root over chi-square divided by n into minimum of r minus 1 c minus 1. So, chi-square is 3.74 divided by n is 72, r minus 1 and c minus 1, both r and c, number of rows and number of columns are 2, therefore, r minus 1 c minus 1 is 2 and the minimum is 1. So, Cramer's V is root over 3.74 divided by 72 into 1, which is 0.23. So, we have now calculated two measures of association. So, one is the chi-square and the other is the Cramer's V. Now, if we look at another type of data, let us say we look at another type of data where the same 40 and 32, instead of 12, 17, 28 and 15, let us say we had 2, 27, 38 and 5. The artificial or computed proportions would still be the same as 16, 13, 24 and 19. Let me show how this 16 was obtained. So, this 16 is actually 29 out of the 72 are fresh graduates, and therefore, proportionately out of the 40 people, how many are expected to attend. So, that will be 29 by 72 into 40, which will be 16, and the other number will be 43 by 72 into 40, which is 24. So, this table will remain the same. For example, those who skip will be 29 by 72 into 32 and 43 by 72 into 32, which are 13 and 19, and we would get a different kind of a difference in this, and chi-square would become 45.81 and Cramer's V in this case is 0.7976. Now, the general guideline is V less than equal to 0.25 shows a weak association, and Cramer's V greater than or equal to 0.75 shows a stronger association. So, when we started with this example of 12, 17, 28 and 15, we calculated the Cramer's V to be 0.23, and therefore, we would say that there is a weak association, or one could conclude based on this example that one cannot say with certainty that there is a strong association between the type of student and the tendency to attend or to skip. So, V greater than equal to 0.75 shows a strong association, and we can now say there is an association, and one can generally conclude that people with work experience tend to attend more classes, while fresh graduates tend to skip classes. So, there is an association between the type of student and the decision to attend or skip. Therefore, we end the discussion on association between categorical variables using two metrics, primarily the Cramer's V, which comes out of the computation of chi-square. So, Cramer's V less than or equal to 0.25 shows a weaker association, and a Cramer's V greater than equal to 0.75 shows a strong association. For example, when we looked at the other data, when we looked at this data, the Cramer's V was 0.23. If for some reason we had this kind of a data with 2, 27, 38 and 5, and the proportions are 16, 13, 24, 19. I am not saying that these were obtained based on the earlier calculation, and if we had a situation where the differences were large in this, which resulted in a large value of chi-square and a large value of Cramer's V, then we would say in this case there is a strong association, which means one could say that people with work experience attend large number of classes, while fresh graduates would skip a large number of classes. So, now let us have a discussion on association between categorical variables, and let us start with match the following. So, column A has about 8 pieces of information which have to be matched with column B. So, table of cross classified counts is called a contingency table, and we have seen that. So, there is a cross classification across two types of categorical variables. So, shown as a bar chart, so marginal distribution can always be shown as a bar chart. Measure of association between categorical variables. So, in this we could either give chi-square or we could give Cramer's V, and the example is chi-square. Measure of association that lies between 0 and 1, and we can now show that the Cramer's V lies between 0 and 1, and it is a measure of association between categorical variables. So, we get Cramer's V in this. Produced by a lurking variable, we just now saw that Simpsons Paradox is the example, and that happens because of a lurking variable. When conditional distribution matches the marginal distribution, then there is no association in the data, which means the proportions actually match. The percentage within rows differs from marginal percentage, then there is association, and cases that match two categorical variables is a cell in the table. So, this kind of helps us understand the basic concepts. It also tries to tell us what is a contingency table, what is a cell, what is a marginal distribution, what are the methods of association, and when do we have association and when we do not have association. So, let us continue with some true or false. We can fill cells of contingency table from the marginal counts if the variables are not associated, true, because the proportions will match. The value of chi-square depends on the number of observations in the contingency table, true. Larger the number of observations, more perhaps the value of chi-square will become. Cramer's V is 0 when variables are not associated. When the variables are not associated, the proportions are the same, therefore, the difference will be 0, and therefore, chi-square value will be 0 and Cramer's V will also be 0. The value of chi-square depends on which variables define the rows and which define the columns. It is false. If we interchange the rows and columns, the chi-square value will remain the same. If male and female are values of a variable, and if the percentage of females is higher, then there is association between variables. We cannot say that. It could be false, because the other variable could be such that there is no association between male and female with respect to the other variable. Now, let us try to look at a few simple questions. Now, customers were asked to give preferences for color and shape of a product. two teams were created, each to determine the color and shape of the product. Is it necessary to check if the two variables are associated? Yes, it is actually necessary to check. It will be actually good if there is no association, which means the teams can work independently. Otherwise, the association has to be taken into account in the combination of color and shape that the company finally chooses to have for the product. Question number 2. Survey was conducted to understand the reason for absence of students in a university. The main reasons were identified, and there were 3 broad categories of students. In which group the medical reasons dominated? Are they associated? So, the 3 groups are age groups of 20 to 30, 30 to 40 and above 40, and this is the contingency table. So, we can see from this table that the group of 30 to 40 have a higher family reason, and whereas above 40 had a higher health or medical reason. It is possible to find out the association using either chi-square or Cramer's V. Cramer's V being a method that also uses chi-square, we can do that. A survey was conducted in a supermarket where 2 variables were considered. Let us assume it is a 24/7 supermarket. So, 8 AM to 8 PM purchase and 8 PM to 8 AM purchase, and 2 types of customers, family and single. Would you expect association in the data? Yes, that we expect association in the data, and we would expect that more families would come during the 8 AM 8 PM, and perhaps there will more single people would come during the 8 PM and 8 AM. Survey indicated that the most popular color for all cars is white. Should a dealer stock all items in white? Now, we need to check an association between the types of buyers and color. So, we might have a situation where as in a certain type of buyers, white may not be preferred, or there could be lesser association, and then we have to find out, and perhaps the dealer has to stock other colors of cars as well. Now, we looked at last question, find the Cramer's V for the following data. Let us assume that red, blue and white are, for example, 3 colors of cars, and the other 3 here are people with income more than 30 lakhs, less than 15 lakhs, between 15 and 30 lakhs and so on. So, in order to find the Cramer's V or chi-square, we first try to find the proportion. So, we answer this question: if out of 315, 70 people have a red color car, now how much out of 90 would have a red color car? So, the proportion becomes 70 by 315 into 90, which happens to be 20. So, if we calculate the remaining numbers, which you can do now using the similar formula, you would realize that the values are 20, 30, 40, 10, 15, 20, 40, 60, 80, and the same table repeats when we actually calculate based on the proportions, from which the differences will be 0, chi-square will be 0, and Cramer's V will also be 0. So, with this we come to the end of this lecture, and in the next lecture we would study association between numerical variables.